What you saw in the last lecture was the classic example of polymorphism. So to achieve polymorphic behavior, we start by defining a base class. And in this class, we define the common behavior or the common methods that we need in its derivatives or children. With this, we achieve polymorphic behavior in our draw function on line 22. So depending on the type of control object that we're working with at runtime, this draw method takes a different form. It might be the draw method in a text box or a drop-down list or radio button and so on. So this is how polymorphism works in pretty much all languages that support classes. But because Python is a dynamically typed language, we don't necessarily need this UI control as the base class here. In other words, if we get rid of this class, let's just delete it for now. We should also delete it from these two places. With this change, we can still achieve polymorphic behavior. Why? Here is the reason. Look at this controls parameter. Nowhere here we have specified the type of this parameter, right? This is purely a label, a name. We can pass any kind of objects to this draw function. As long as that object is iterable, Python will be happy. Because here on line 15, we are looping over that object. So that object has to be iterable. So technically, we can pass a string, a list, a tuple, a dictionary, anything that is iterable here. By the same token, that iterable object, its individual parts, should have a draw method. So Python doesn't care if these objects derive from the UI control class. As long as these objects have a draw method, Python will be happy. This is what we call duck typing. So if it walks like a duck and quacks like a duck, it is a duck. That is how Python works. Because Python is a dynamically typed language and it doesn't check the type of objects. It only looks for the existence of certain methods in our objects. In other words, in this case, on line 16, it only looks for the existence of the draw method. So if this object has a draw method, Python assumes it's a UI control. It's exactly like saying, if it walks like a duck and quacks like a duck, it is a duck. So to achieve polymorphic behavior, we don't necessarily need a base class like UI control because Python supports duck typing. Having said that, having that UI control as an abstract base class is a good practice because it enforces a common interface or a common contract across all its derivatives. With this, we'll make sure that every kind of UI control will have a draw method.